Okay, let's look at the homework 15, problem number 1. Alright, so we want to use this change of variables to evaluate this double integral here. Alright, so first we're going to figure out the region we're integrating over. Alright, so here looks like we're fixing y, then x is going to go from x equals 0 to x equals 1 minus y. Alright, so x equals 0 is the y-axis, which is right here. Alright, and x equals 1 minus y is, if you solve this guy for y, you get x equals 1 minus y. Alright, so then I'm going to just put negative y on this side and over here. So you have y equals 1 minus x. Right, so that's just going to be a straight line, and y-intercept is 1, so it's going to be here. Right, then slope is negative 1, so it's going to go through right here 1. So it looks like just a straight line going like this. Right, so it's kind of like that. Right, so that's going to be the line there. Right, so this is right, x equals 1 minus y. Right, maybe I should draw x equals 1, x equals 0, which is right here. Right, so here this is just line x equals 0. Right, then you can see that the y is going from 0 to 1. Right, so y is going from 0 to 1. So we can see that we are shading this region right here. So this is the region we are talking about. Alright, so this is the region in XY plane. Now we're going to convert it into the region on the UV plane. Right, so easiest way would be we're going to just take the, since this is all linear, so I'm going to just take corner points. So this point right here and the origin here, and that's 1, 0, and see these where these points will go. Right, so we plug in, so let's try 0, 0. So x equals 0, y is 0. Plug in 0 here, so u is 0, and 0 here, 0 here, v is 0. So origin is going to stay at the origin. So I'm going to just put it here. Right, maybe I'll do a different color. So say I'm going to use a red. Right, so it's going to go here. Right, and let's try this point right here, which is 1, 0. Right, so x 1 and y is 0. So x is 1, y is 0. So u is going to be 1, and v is going to be 1 as well, 1 plus 0. So we're talking about 1, 1. Right, so let's put here's 1, and probably around here. So you have 1. Right, then so we have a point right around there, so I think it's going to be around there. Right, so 1, 1, so right here. Right, so this point will go there. Right, then 0, 1. Right, so this point is 0, 1, and if you do that, you see that u is going to be 0 minus 1. So u is going to be actually negative. Actually, I have to move this guy a little bit, and hold on a sec. Alright, I extended the u axis in the negative direction, and looks like 0, 1, so it's going to be u is going to be negative 1, so which is right here, and v is going to be 0 plus 1, so it's going to be 1. So negative 1, 1 should be right around there. Right, then we can sketch the region. All right, so let's see. So the region is going to be still a triangular region. So you see that this, and connect these two dots together, and connect these two dots together. All right, so we're talking about this region. New region is this region right here. All right. Right, so if you were to write the equation, this equation is equation for that boundary would be v equals 1. Right, so this guy is going to be slope is 1, so it's a v equals u. Right, this guy is slope is -1, so it's v equals -u. Right. Then next thing we need to do is let's see, we need to find the Jacobian too. So let's find the Jacobian. Right, so in this case it's written as u equals v equals, it's probably easier to find the Jacobian of u comma v, and with respect to x comma y. All right. Then let's just do that. So it's going to be partial of u with respect to x is going to be 1. Right, partial of u with respect to y is going to be -1. Partial of v with respect to x is 1. Partial of v with respect to y is +1. Right, so this will give you 1 times 1 minus -1 times 1, so +1, so it's going to be 2. Right, but we have to be careful. The Jacobian we really want is going to be the reciprocal of this, because we want the partial with respect to the old variable, which is x comma y, and with partial with respect to u and v. Right, so but all you really have to do is take the reciprocal of that, so it's going to be 1/2. Right, so let's rewrite this double integral here. So I'm gonna just give myself a little bit more room by just moving this guy over here. All right, let's write the integral. Right, so this is going to be equal to, right, so we have double integral. Right, so we want to rewrite this function in terms of u and v. This is actually fairly easy. E to the, right, on top is u, on the bottom is v, so u over v. Right, then you have to put a Jacobian. A Jacobian is going to be 1/2, so times 1/2. Right, then I'm gonna fix v first. Then so we do a integral with respect to u first. Right, then we do integral with respect to v. Right, so we have to actually kind of rewrite this guy as this can be written as u equals -v, and this is just the same as u equals v. Right, so you can see that for fixed v, right, you have to go from this point all the way through that point. So u is going to be u is -v all the way to +v. Right, then once you've done that, in order to cover the entire shaded region, v is going to start from here, then gradually increasing the value of v, and to cover the entire region, v is going to go up to +1. So v is going from 0 to +1. Right, so that's the double integral that you need to evaluate, and I'll let you guys do that. So I'll say dot dot dot, then you have to get the value for it. All right, that's it. I hope that this will get you going.